All right. I think that's pretty much everybody who's going to come right now. Uh, Other people might be joining a bit late. They might join us a bit late. So, hello everybody. Again, my name is Yusuf, and alongside me is my partner Ahmed. And welcome to the day 2 of training. So today is going to be exciting. Today we're going to move on in the material. We're going to have a lot more fun. And we're finally going to get to hacking services, submitting flags, and moving up on that scoreboard. All right, so let's start by, I'm going to start by sharing my screen. Right, and you guys just give me any signal that you can see.
Yes, we can see.
All right, thank you. So let's take a look at the scoreboard, which is the biggest thing that has changed. All right, so as you can see, there are some teams who were very busy all night, and they hacked all services. So you can see that all 4 services have been hacked and flags are being stolen from them. And so they moved up on the leaderboard. Some teams only managed to exploit 2 services. Some teams got 1 service, and it's fine for the rest of you that you didn't do much, which is fine. Some teams are going to jump a little bit ahead. Maybe they have experience with the platform. They've done this sort of thing before. And that's more than fine. Okay. Don't get demotivated. Don't think, oh, we're going to get destroyed now. There's no point. No, there's always a chance. Right. If all of you were put on equal ground, things would be a little bit more different. All right. Especially since some of you attended the training so late at night and you had to sleep after it. So don't worry about it. Now I can see that a lot of you guys have your services as down. Like a lot of teams have their services as down. And I think I know the issue behind that. So I need everybody who's here to SSH into your virtual machines, okay, as I am right now. And I need you to do df-h/. Now, if your virtual machine tells you that you have no space left, you have 0 GB of space left, then you probably left your TCP dump command running all night and it just made 150 GB PCAP file. And so the system has no more space. So your services are down. So if that is the case, go into your TMUX sessions or go find the TCP dump command that was running and kill it and remove the PCAP files. All right. Now for everybody else, if you're now once you guys, I'll give you a couple of seconds to remove the PCAPs and fix your space issues if that is what happened, because that's what happened to me as well. I logged in and I had 0 GB of space. So I was like, oh, I left the PCAP running all night by accident. So here we go. Usually in the competition, you would remove the PCAP every once in a while. You would clear it, just empty it. Obviously, nobody needs 150 GB PCAP. So I'm assuming now that most of you have logged in and you've started to, fix up everything. So the first thing we're going to do is we're going to restart our services. Now you have 2 ways of doing this. You can either restore the snapshot that you took yesterday, the initial snapshot that you took yesterday from the cloud console, but you'll lose anything that you might have installed on the machine, especially Caront. So if you set up Caront with me yesterday, you will lose it if you restore your snapshot. However, you can reinstall it if that's what you want. If you feel like it's better to just go back to a default state, especially for those of you who might have issues SSHing into their machines in the first place. If you can't even, like, your machine is not even responding to you trying to log in, it's best to just restore the snapshot. All right, and you can install Caront again. You guys have the slides and you have all the material. So speaking of slides, I'm going to drop in the slides here for some people. Actually, I'm going to wait a bit before I drop the slides because I feel like some teams are going to just get too excited and go and start exploiting, and that's not quite what I want them to do right now. So I need you guys to stay with me as much as you can. I promise we're going to get to the exploiting part as fast as possible. So let's restart our services, since most of our services apparently on the scoreboard are mumble and down. So you're going to go to /home. You're going to see all your different services. You're going to go into your services one by one. So I'm going to start with Coffee Pot, and you're going to run the following command: docker compose up --build --force recreate and -d. So what this is doing is that we're forcing the container to be rebuilt from scratch again, and we're redeploying it, and we're putting it in the background. So we're letting the container run in the background. This is to restart all our containers back to the initial state so that any exploits, any issues that might have happened are now gone. So I'm going to copy this command if my terminal would let me and paste it here. Okay. All of you go one by one into your, so I'm going to do this on CoffeePot. And that just rebuilds the CoffeePot container. It's recreating the service right now. And it's done. All right. And now I'm going to go back. So I'm going to go back to home. And there's another service, Free Life. So I'm going to go to Free Life. I'm going to paste the command again. I'm going to rebuild Free Life. That's it. Free Life is done. We're going to go into the next service, Health Monitor. We're going to rebuild Health Monitor. There we go. And nope, I wanted to type ls. We're going to go into Nasarasa, our final service, and we are going to rebuild Nasarasa. All right. Now I have a feeling someone must have probably logged into my current overnight and just destroyed it. So I'm just going to stop my current service. You guys can feel free to leave your current services running as long as you guys just double check on your current services, double check that you guys added authentication and everything is going well. Other from that, I'm going to take mine down because I don't need them anymore. If you guys also feel like you don't need your current services, you can do Docker Compose down inside current. All right. And we're back to how we were. So all my services should be up. If I go to the scoreboard, I am org1. Where is org1? Org1, and you can see all my services are green up. And I'm going to explain what the scoreboard means. You guys are seeing a lot of numbers here, and I'm going to explain what all these numbers mean. Okay, let's start with the colors you're seeing here. All right, so let's look at green. So these arrows at the bottom under each service, that means the service is up, and this is the percentage SLA. Okay, so this team has 94% SLA, kind of. All right, they've been up 94% of the game. All their services have been up 90+%. Some people, for example, like team number 6 right now, or in the 6th position, has most of their services are down and they've been up only 26% of the game. Some teams, their services are mumbling, so they're sort of working. You know, mumble, I thought we discussed mumble yesterday, which means that the service isn't working properly. So this is probably they tried to patch their service and they didn't patch it properly. Most of services are mumble. These could be as a result of exploits, like bad exploits that destroyed the service, and that's fine. All you got to do is reset your containers and you're going to be as good as new. So I can see a lot of teams now have started to restart their services and your SLA is going up, as you can see. Your SLA, see here, so the average SLA, you can expand your team. You see the average SLA is 52 and flag points. And this number right here is your flag points. That is your score and it's affected by SLA. Now, flag points are separated on each service right here. So they earned 34,000 points from CoffeePot, 240 points from Free Life, 188 Health Monitor, 283 NASA Rasa. And you can even see these smaller numbers under each service. So this is how many flags have been stolen. So they stole 1,084 flags from CoffeePot. They stole 8,000 flags for Free Life, 4,800 for Health Monitor, and so on. And in the red, that's how many flags they lost, how many flags were stolen from them. All right. And you can see here in the bottom a total. So in total, they stole 22,000 flags almost, and they lost only 175. So this team really patched up their services as fast as possible. You can even see that there's a team here that never lost a flag in CoffeePot. So they probably found the bug first people, patched it, and they called it a day. All right. So let's keep going. So this scoreboard is definitely going to change overnight. You guys can ignore these teams that were busy all night, okay? And you guys can just focus on yourselves. You can keep going, all right? It's just a training anyway, so stay motivated. It's all about the experience. It's all about the fun. It's all about finding the exploits and writing them and getting used to the whole thing. So with that being said, let's move on to our material for today. This is yesterday's material, and welcome to day 2 material. So, let's get started. Today, we're going to be explaining what you should expect when you look at a service's code base. What we mean, like what files do you expect, how you should expect everything to be assembled. Then we're finally going to get to the good part, which is finding vulnerabilities in our services. We're going to be exploiting them and patching them. And then we're going to learn about something called an attack defense exploit farm. And these are amazing tools, just like Current, that really help and can make a big difference in how efficient you are in capturing flags in an attack defense competition, right? So let's move on. So let's talk about flags. Although we kind of did talk about this yesterday, flags are usually found and stored in databases in services, but can also be found in the file system in some cases. It all depends on the vulnerability. So remember, I told you guys when your services start up, you should pay attention to when the check system inserts flags into your system and where do they show up. So for example, let's take an example here. Let me log into my NASA RASA service. So 10.60.100.3. NASA RASA runs on port 80. Okay, where are the flags? So I can go to users. Oh boy, someone had a lot of fun here. How am I supposed to? Okay, well, this is what happens when you have 20,000 people exploiting your service. Things happen. I have no clue how I'm going to be able to find the service right now. Find the actual user. Please. You know what? We'll check on this in a second. We'll come back to the service in a minute. This is all automated exploit scripts that are signing up for the service. Because part of the vulnerability is pretty much signing up. Come on, waiting for the check system to drop in a new. So we know that the check system drops in new flags every 60 seconds, which is how long a round is. Okay, here we go. Finally, so we see a bunch of exploits happening here, and then we see a user that got put that's out of place called, it's just 2 names. So we see this user, we see that they registered as some random generated username. And if we somehow go into the database and look at this user, you're going to find out that this user actually uploads a flag in the description of their profile. Okay, so you somehow have to find a way to log in as this user and take the secret private message that they can put under their profile. That's the flag. So we're looking for some sort of authentication bypass, authentication bug. All right, you can find out more and more by exploring the code, but you have to be familiar with your services. Watch where the check system uploads flags into your services. Current can help with that. You guys can watch when the check system is putting flags in and just track where they end up landing in your system. All right, so moving on. We know that the flag format is this regex, so 31 random characters, and it ends with an equal. And this is an example. And your goal is to steal these flags from the other team's services and submit them to the check system to gain points, right? So the game time is split into rounds, all right? And in Hack in the Box, these rounds are 1 minute long. So every 60 seconds, check system is going to add new flags, and the check system is going to check your services every minute. And the flags that are valid for being submitted for submission are the flags that have a lifetime of 15 minutes. So flags expire 15 rounds later. So if you try to submit a flag and it's been in the game for 14 minutes, it will be valid. But once it becomes 15 minutes old, it stops being valid. So you should try to limit yourself, try to ignore any flags that are older than 15 minutes. All right. And we'll talk about this more when we're talking about building exploits and exploit farm and all that. So service code base structure. Each service, as we know, has a Docker Compose file and a Docker file, which contain information about how the container is built and deployed, what libraries are being installed, what system packages are being installed, all that stuff you can find in the Docker file and Docker Compose. And depending on the language that the service is written in, the logic can be in a few files. For example, you might just be lucky enough to have main.py, and that's pretty much the entire service. Or you might be unlucky and you'll have a big Django service. So if you've ever dealt with Django in Python, you know that it's like 300 files all over the place, each doing a different thing. All right, that's why it's recommended that if you see a bunch of files, you see a framework that you're not familiar with or a language you're not familiar with, it's best to Google, because sometimes some of these files are going to be, just they're not useless, but they're generated by the framework or by the language. They don't actually contain any logic there. All right. And you're going to see examples of this in a second. So what are the services that we have? We have Nasarasa, which is a PHP web app with an exposed MySQL database. We have Health Monitor, which is a web app written in Go. All of these are web apps. You have CoffeePot. It's a CGI script written in Bash. And FreeLife. It is a Django web app written in Python. So we have PHP, Go, Bash, and Python. 4 different languages, 4 different frameworks. It's all different, but they have one thing in common. They're all web apps. So the first thing we're going to do is we're going to talk about techniques to finding vulnerabilities. But before that, let's take a look at the code, shall we? Let's just double check what I just said. So let's just go to home. So I'm going to go to home. Okay, and we have the 4 services. I'm going to list CoffeePot, and you see that there's a second folder inside it called CoffeePot service. So when I list it, there's another folder. I see a Docker file, which can give me an idea. So let's cat this Docker file. Let's read this Docker file. So I see that we have Ubuntu 16, and we're just copying a bunch of, so we're adding the CoffeePot folder into the container. We're running some permissions, and we're basically just running the CoffeePot web server. Wow, that's pretty much simple. Okay, let's take a look at the source code. So CoffeePot, CoffeePot service, and CoffeePot. You'll see here that we do have a CGI script. So that's how you can tell. You just see CoffeePot.cgi, and that's pretty much all you need to know. So take a look at CoffeePot CGI, and it's essentially a CGI script written in Bash. And we'll talk about this. We'll explore this later. All right. The next service, FreeLife. Let's see what's inside FreeLife. We have another Docker Compose file. So let's open FreeLife. We see that FreeLife is actually just straight up a Python Docker container. So we know it's a Python web app. They're adding, and it says right here, install Django, and just pip install Django, and they just run the Django web app. So you start to see keywords, Django and Python. It helps you Google. Let's look at Health Monitor. Let's read Health Monitor's Docker container. So cat Health Monitor Docker file. We see immediately it's a Golang container. It's a Go app. You can see that they're initializing and they're building the service, and they just run Health Monitor after it's been built. So now you know that it's Go. So you see the Docker files really can give you an idea about what to expect and what's happening. So in Nasarasa, it's not that simple. We have to cat the Docker file. We see again, it's PHP. It's a PHP container running Apache, and they're just copying code in. They're installing some PHP extensions like MySQL and that stuff, and they're just running the service. Okay, so these can give you hints, and it's always important to look at these Docker files. What if they're installing, like for example, that Ubuntu 16 container? Does it have any default packages that might be vulnerable? Does it have are they doing anything specific in the Docker files? Are they installing any specific libraries that might be outdated, or they're doing any specific practices? And we're going to talk about that. So first thing you should do is check the Docker related files. Also look at the Docker Compose files as well. Is there any specific version of any libraries being installed? Are they outdated? Are there any specific system settings that are being applied that are insecure? Are there any exposed services with weak or even no authentication, or even hard-coded creds? The second thing you should do is just go through the code like any normal defender would do. Open the code in your favorite code editor and just walk step by step. Look at all the lines, try to find something that just looks out of place. Or the third option is, well, if you kind of give up on a service, or you just don't want to bother going through, trying to go through the code, wait for another team to exploit it and then just steal their exploit. The three of these are perfectly valid strategies. So for our first break for today, I know the break came in a little bit early, but we're going to give you guys a hands-on activity. I want you guys to go take a look at the Nasarasa service. Okay, use the 3 steps that were mentioned in the previous slide, and I'm gonna keep it like this. Okay, and go ahead, take a look at the Nasarasa service. I'll give you guys 15 to 20 minutes. Come back in 15 to 20 minutes. take a look and try to see if you can find the most obvious vulnerability. Now, don't patch it yet. Don't touch anything. If you find out, that's great. Don't touch it because we're going to need it in a second. But find out what it is. All right. And we'll be back in 15 to 20 minutes. All right. I'll put a timer for 20 minutes. See you guys in 20. Hello and welcome. Welcome back, everybody. I was literally eating a sandwich and I saw that we had 30 seconds left. I had to eat the sandwich faster than I've eaten anything in my life. So let's come back to the presentation, come back to the Zoom call, everybody. So what do you guys think the vulnerability is? Talk to me. What do you think the vulnerability is in Nasarasa? Most obvious thing. Nice. That's correct. The exposed MySQL database. Everybody has the same credentials. Everybody has access to the database. Why even bother trying to hack the service? You can just log into the MySQL database and grab the flags. And that's what we're going to be talking about. That is our first vulnerability. Good job, guys. So by looking at the Docker Compose files, you found out that, hey, let's look at the Docker Compose file. They are specifying a MySQL user and password directly in the Docker Compose file to the service. Like, that means all the other teams have the same username and password combo, and all the other teams have the same Docker Compose file, meaning that we can just log into other people's databases and call it a day. I will share the PowerPoint now. So now that we've talked about the first vulnerability, and things are going to be a little bit chaotic now, but I can share with you guys the day 2. Here we go. That's day 2 training. So now that you guys know this, I know some of you are going to just go and run to your databases or run to your command lines and try and log into as many teams as possible. But I need you to stay with me for just a second, okay? Because we're going to talk about exploit writing. All right. So now, in the case of Nasarasa, the flags are stored in the message column in the planets table, and we can check that. So I'm going to go MySQL. I am logging in as Nasarasa. The password is, and I'll just copy the password from the Docker Compose. Should have another SSH terminal here. Let me just cat Nasarasa Docker Compose. Let's run MySQL. Do I even have the MySQL client? Please, MySQL. No, I don't. So sudo apt install MySQL-client. Thanks, Hamid, for the password. So now I have the MySQL client. Let's, yeah, oh, you sent the password here. Thank you. So MySQL, let's first connect to my own database. So Nasarasa, password like this. I'm connecting to the Nasarasa database. Oh, I forgot to include the most important thing, -h host 127.0.0.1. I'm connected to myself and I'm logged in. There you go. I can say show tables and I see that there's planets. So I can do select star from planets. And there we go. You see all these flags right here. All these flags in the message column. All right. And you can see some people are also trying to test on my service for some SQL injection. All right. So I see Poon stars and other people left messages here. That's nice. And that's basically the flags. So you can do select message from planets. Well, oh, who dropped my database? Thank you, guys. Someone just logged in and just dropped my database. I mean, makes sense. So good thing that someone did that. We can talk about that. So let's say you find a vulnerability like this, like an exposed database. Okay. Are you allowed? Oh, this is going to be important. Are you allowed to go in and mess with other teams' flags? The answer is no. All right, because it's not fair. Because right now I'm going to lose SLA. Why am I going to lose SLA? Because my flags are, and my service is going to show up as corrupt because I lost all my flags. All right, the check system is going to try to retrieve previous flags, but it can't do that anymore because someone dropped my database. All right, so I'm going to start losing SLA. And another thing we're going to talk about, you can't put in fake flags as well. So let's say you have a regex right here, right? I can't just start copying this regex and flooding people's databases with flags. You're not allowed to do that. And this is funny and everything. We can laugh about it. That's I actually did not see this coming. So good job to whoever dropped my database. But one very important thing, if you do this in the competition, it might be fun for a couple of minutes, but then you'll get banned. All right, because it's not fair. You can't drop flags and you can't add flags either. Right? It just confuses other teams. It causes them to lose SLA, and it's not their fault. And it's not okay. All right. You can steal flags silently. Go ahead, live life. But you can't start, ruining their service on purpose. All right. And be careful. All traffic in the competition is monitored. So if you start doing this and teams start complaining that, oh, my database keeps getting dropped every round, what's happening? Very simply, the game admins, they'll go to the game router, they see all the traffic, and you'll be found out in a couple of minutes, and that's it. You don't want to be disqualified over something like this. And in attack and defense, a very big point. So I know that was a little bit serious. Just don't worry, that's fine for now. But in the actual game, attack and defense, the goal is to be as stealthy as possible. You don't want to be found out. You want to be silent. Imagine how loud it is to drop another team's database. Imagine how loud it is to just wipe their database or flood their database with flags, right? So you're not allowed to do that, okay? In any way, shape, or form, even if you have code execution, all that stuff, don't do that, all right? So moving on. I'm gonna have to wait. So whoever dropped my entire database, I have to rebuild my service now, hoping that it comes back up. So build. All right. So I'll wait for my database to come back up and we'll give it a couple of seconds. So how do we patch this? But moreover, instead of talking about patching, let's talk about exploiting, right? So we want to automate this, typing in MySQL every single time and like changing the IP address. So I want to log into a different team's database, 10.60.101, for example, .3. I think 101 might not be up, or maybe they changed the password, maybe 102. Maybe any other team. Anyone? 20? No. 51? Okay, 51. No, you guys, you can't change the password. You need the password to be unchanged. So if I can't log in because the password is different, there's no point. 32, 45. All right, so I logged into 45 immediately. So as I was doing select message from planets, no, why is it also empty? Did someone, is it actually called message or? Yeah, it's called message. Ah, someone emptied everybody's databases. someone just destroyed everyone's database. That is interesting. I wonder if that's automated. That can't be automated because my database was filled a couple of seconds ago. Come on, I need to just find any team whatsoever, anybody. You know what? I'm just gonna find a team. Team 7. All right. Thank you guys. All right, let's see. Did someone really just wipe out everybody's database? No. Okay. So you guys can check your own databases. If you got wiped out, just follow what I did, which is I rebuilt the database. All right. And hopefully they'll just leave you alone for now. So see, the reason why this is unfair, you'll go right now and you'll check the scoreboard. So right now, you'll see that most of our services, see everybody's NASA RASA service, corrupt, and you're losing SLA. And you're gonna lose SLA for an entire 15 rounds. Because remember, we said that valid flags are 15 minutes long. So the check system needs to find those flags. So I'm gonna lose flags for the next 15 minutes. I'm gonna lose SLA for the next 15 minutes, and that's not fair. So when you guys find a vulnerability like this, like an exposed database, like an exposed no SQL database, or even an SQL injection, like an SQL injection vulnerability, anything at all. You can't mess with existing flags, right? You can't. You're not allowed to just go in and wipe the databases clean. That's not fair. Okay, so right now we're going to talk a bit about exploiting. So don't patch it yet. It's a very simple patch, but don't patch it yet because I want to show you guys the exploit, how it works and how it's, and like, how it actually works. Ahmed, if you're here with us, can you please make sure that the organization 2, can you go into the VM and restart all their services? Because I think if everybody patches, at least I can have one person to hack.
I think organization 2 is me, right?
Yeah. So I'm telling you, fix. All right. Let's get started. All right. Okay, Hamad. Thank you. So let's move on. We need to steal flags and we need to submit them to the check system. All right. And we're going to need that same secret team token. So you guys remember that token that you guys used to log into the cloud console? You need that. And so this is the curl command. So how do you submit flags manually? Let's just assume you want to submit a flag manually. You have to send an HTTP put request to 10.10.10.10/flags, okay, with your team token in the header and the flags in the form of an array in the body. What does that mean? So let's come here. So I'm going to take this curl command and I'm going to put it here. Let's see, what does that mean? So you see this curl command? I'm adding a header here to this curl command called xteam token. Okay, and in this I'm going to put my token. Okay, so I'm going to put my token in front of you guys because I trust you. There's not really much you can do with the token anyway. Where is token? Token. Okay, and you see this array right here? This is an array of flags, right? So I'm going to come here and I'm going to remove this and nope. Okay, I accidentally submitted it. I didn't want to do that. Okay, and I'm going to put here a real flag instead. Okay, so let me log in, for example, to some random person's database, select message from planets. Okay, let me grab one flag, the latest flag, thank you. Go back to my curl command and replace this with the flag. All right, and it says here, flag accepted. I got 37 points, 37 flag points. And that's it. That's how you submit flags. So if I go to the scoreboard now, I am marked as org1. All right. When the scoreboard updates next round, I will jump by a lot of points because I just submitted a flag. We can even refresh right now just to force it to update. All right. So the check system needs to catch up. But yeah, that's how you submit flags. That's pretty much it. You grab flags and you send them with a curl request or an HTTP put request, and that's it. Now, I know you guys are going to be busy right now trying to steal everybody's flags. Everybody's trying to steal everybody's flags and submit them for some points. And you can go ahead, but if you stick with me, if you stay with me for a second, I'll show you how you can get a lot more points much faster. So you don't have to do it manually yourself, even faster than a Python script. Okay, you can see right now that I jumped to 8th place. And it even says I stole 38.26 flag points. Okay, notice how my service is still corrupt. I'm still losing SLA. Can you imagine? So again, deleting flags and messing with flags is a very serious thing. Don't do that. Right. So let's move on. So we just successfully submitted our first flag. We stole our first flag and we submitted it. That's great. Awesome. What now? I want to automate this. I want to write this in a script. So let's talk about writing scripts. Obviously, the best language I can recommend is Python. However, you are more than welcome to write exploit scripts in any language you pick. Hell, if you want to write an exploit script in assembly, I mean, you're going to waste a lot of time, but nobody's stopping you. You're more than welcome to, but you're just going to waste a lot of time. And Python is great because it has a lot of libraries for very quick. Let's say you want to interface with a Mongo database very easily. You'll just Google Mongo database Python library, and that's it. You'll be good to go. So I recommend Python 2 or 3. That's pretty much your choice. I would recommend 3. but Python is the best language. But if you write Ruby, for example, another scripting language, that's fine. You want to write Go for concurrency. You want to write JavaScript. I don't know why you would do that. Any language, up to you. All right, just Python is best. You should always learn Python. So let's talk about the format. How should you write exploits? Now, I'm specifying a specific format. You're pretty much free to pick whatever format you want. You can write your scripts in whatever way you want. But the reason why I am telling you to use a specific format is because we're going to later import those scripts into something we call an exploit farm. And you'll see how amazingly useful this exploit farm is. You'll see how important it is. All right. So the exploit script should take a single IP address as a command line argument and print every flag that it steals separated by a new line. All right. And it's recommended, it's very recommended to include some hard-coded timeouts in your script. So let's say timeout of 20 seconds, 10 seconds, because some teams might slow down their service on purpose. So some teams might make it so that their service responds in 40 seconds. You know, they throttle the internet on their service. Okay, so that means your script will just stay there waiting forever, hoping to connect to the database, and it might take 40 seconds, which is a lot of time, reducing the chances that you exploit another team. All right, so let's move on. So this is the exploit script that I wrote for NASA RASA's open database, right? And I'm going to open it up for you guys right now because I need to change actually a couple of things about it. So it was in right. Let's open the exploit folder in Visual Code, my favorite code editor. So nope, not the service exploit. We want the database exploit. So you can realize here that this exploit connects to exposed MySQL and steals flags. Okay. I import a PyMySQL library and I import sys. And the reason why I import sys is, like I said, the argument, the IP address is the first argument on the command line. So I take the argument, which is the host we're going to attack, and I save it. I have hard coded here the username and password that we're going to use. Very simple script. I just connect to the host with the username and password. I'm connecting to the database, the NASA RASA database. I have a connection timeout of 10 seconds. And don't worry about cursor class. This is just straight up from the documentation. All right. If any exception happens, incorrect password or timeout or anything, just exit the script. I don't want to waste time. Okay. And then I'm selecting message from planets where, and then there's a field called added at. And this is just me checking that the flag is 1 minute old. And you know what? We can remove all of this. All of that. You can remove all that. Give me all the messages. So give me everything, all the flags in the planets table. And we're going to talk about why. You might be wondering right now, oh, what if the flag is expired? What if it's old? What if it's duplicate? We're going to talk about that. All right. And all I do is I execute this SQL statement. And for every single flag, I print it on a new line. And then I end it with this print nothing flush equal true. And this is important. It says here, I have a note here that says important for destructive farm. And that's the exploit farm we're going to be using. Okay, it has in the documentation that you should always flush std out at the end of your scripts. Okay, and this is just, you know, if just remember to put these always at the end of your scripts. This print whatever, print nothing flush equal true. Okay, again, you'll have the links to destructive farm. You can go read their documentation and I'll show you how that works. Okay, and this is the exploit script right now. I can genuinely run this right now. I can take this and I can say Python and I want to run this db exploit on 10.60. Let's run it on myself, for example. It connects, dumps all the flags on new line and leaves. Okay, I can point this at team 51. It's taking some time. And again, it has 10 seconds. So in those 10 seconds, if it can't connect, I tell it to give up. And it gives up. Okay, so something went wrong. But a different team, like team 12, again, log in, dump their flags, and that's that. Okay, so there we go. We verified that our exploit works and that it's not going to waste time on databases that might be patched, or there's connection issues, or it's dropped, or all that stuff. All right. So now what? Now what? We wrote our exploit script again, and we want to automate this even further. I want to automate this Python exploit such that every 60 seconds, every round, it will run the exploits again and grab all the flags, automatically read those flags and submit them, and only submit the non-duplicates. Okay, only submit non-duplicates and submit valid flags. So how can we automate that? That is where exploit farms come into play. That's where the most vital component, which is exploit farms, comes into play. All right, and you guys don't worry about trying to screenshot this and copy it down. You guys will have all these scripts at the end, but if you want to follow along, you're more than welcome to. Okay, so using an exploit farm in an attack defense, what are they? Exploit farms are tools that allow for the automatic exploitation of discovered vulnerabilities and the submission of the stolen flags. This allows teams to easily grab flags without having to worry about syncing exploits with rounds, running them manually, validating flags, and all that stuff. The exploit farm that we are going to be using in this training is Destructive Farm. Now, it's called Destructive Farm, and one person told me this. I think it was Andrew. I think it's called Destructive Farm, not because it destroys, but because the person who wrote it is part of a team, a CTF team called Destructive. All right. And this is their documentation. And it comes in two pieces. And we're going to talk about exploit farm right now. You guys are going to set it up with me. We're going to do it together. And we're going to have it running. All right. So setting up Destructive Farm server. So Destructive Farm comes in two pieces, a server and a client. So I need you all to pay attention with me. All right. Follow my commands. First thing we're going to do is we're going to grab this. I'm going to paste it in chat. We're going to install Python 3. So go into your vuln images and install Python 3, right? Give it a second while it runs. And I'm done. So I'm done installing Python 3. Okay, it might take a couple more seconds for you guys, but that's fine. Next thing we're going to do is we're simply going to copy again this git clone command, and I'm going to paste it in the chat. All right. And we're going to clone Destructive Farm. Make sure you're in the home directory, okay? You don't want to be in /home/ one of your services subdirectories, okay? Be in your home directory and just git clone Destructive Farm, okay? Now, we're going to cd into Destructive Farm /server. So we're going to the server folder of Destructive Farm, okay? And we're just going to install the requirements. So pip install -r requirements.txt. So we're installing all the requirements. All right, great. So we installed all the requirements right here. We installed all the libraries that it needs. And how do we get it to run? So one very important thing is that we have to configure Destructive Farm. We have to tell it how to talk to the check system and how often to talk to the check system and how often to, and like how to recognize our exploits. All right. So you're going to find a file in this server folder called config.py. So open that up in Nano or your other favorite editor. And you're going to notice that there's already some things happening here. So let's start with the first line. It wants to know how it can attack different teams. What's the network? And Nano has the formatting a little bit wrong. So Nano is a little bit confused about this and it has this marked as a comment, but it's not a comment. Don't worry about it. We're going to come here to this 10.0.0.0. You see how it's looping? It's replacing the last number with the team number. That's not how it works in our network. Our network is 10.60. And the variable that changes is actually this number right here. So we're going to put the curly braces here instead. And we're going to change this last number to 3. So this is how we successfully loop between all the different teams. All right. And you can even change the loop right here. So you see how it's only looping between 1 and 30? We don't want that. We have like 50 teams here. So you can change that and make it, for example, let's go to the scoreboard and see how many teams are here, although most of the teams are down. So I'm going to say you have about, well, we can't really judge it like that because all these teams are all over the place. Let's just, you know what, for now, let's just keep it 60. Okay. You're looping on 60 teams. You're running the exploit on 60 teams. Okay. So let's save. We have 53 teams exact. All right. I'll just keep the 53 teams here. Thanks, Mohan. So the flag format is essentially the flag regex. And this one actually works. This matches our regex. We have a number of characters, either letters or numbers, 31 times, and an equal sign at the end. So I know some of you are going to be like, oh, but it could be, where's the \W? It's supposed to be a \W. Well, if you guys know regex, \W essentially means A to Z, 0 to 9. Okay. So I'm just going to leave this without saving. All right. And it's back. All right. Now, this is where this section down here is where we configure the protocol that, no lowercase. Flags don't contain lowercase. It's all uppercase. Have you ever seen in any of the flags lowercase? No, it's A to Z. However, \W in Python does contain lowercase letters. Yes, that's correct. But the actual regex is actually all uppercase. If you're feeling kind of panicked, we can just add A to Z lowercase here. It's no worries. Right? Okay. So moving on from the flag format, you can see here that there are some presets. Okay, the presets for check system configurations. You can see this. The one that's uncommented right now is RU-CTF TCP. All right, and that's not what we're using. You actually want to come down here to RU-CTF HTTP, and that is the check system that we're using. And change this IP address, change the system URL to the check system. So 10.10.10.10. And the system token, well, you need to drop in here your secret team token. All right. That's what it uses to authenticate to the check system. All right. And you can come down here and let's look at other things here. So the server will submit not more than submit flag limit every submit period seconds. So every 5 seconds, it will not submit more than 50 flags. And that default is perfectly fine. And we have to tell it here, how long can a flag go on until it's considered expired? Okay. And we can say here it has it at 5 minutes. We're going to just tell it the actual expiration of a flag, which is 15 minutes. Flags expire 15 minutes. Okay. Now, this is the password for the web interface. Now, it's important for you guys to have this, to put this to a strong password, because your server is going to be exposed to everybody on the game network. Okay. I'm going to leave it to 1, 2, 3, 4 because we're all going to have the same service running and there is nothing really you can benefit. So go ahead if you want to log in. I mean, you shouldn't. You should kind of focus on your own service, but what can happen? All right. So now we're done configuring config.py. I'm going to close this. And now that we've configured config.py, we can come here and run start server.sh. All we got to do is do start server.sh like this. And it's running. Okay, of course, you might want to put this in a TMUX session. So let's do that. So I'm going to open a new TMUX session or TMUX, and I'm going to run the start server script there. If you guys are stuck inside TMUX and you don't know how to leave and you're like, what is happening? You just do Control-B and then D for detach. Okay, for those of you who haven't used, I would highly recommend you get used to TMUX or Screen. Both of them do the same thing because you want to be able to run things in the background. All right, so now we have our server running in the background and we can access it on port. Well, I don't remember what port. Let's find out. I must have written it in the slides. Port 5000. Yes. So you can come here and go 10 dot 60 dot 100 in my case, port 5000. All right, so what is the username? That is great. I don't remember that. Let's just come here down to the farm server. More details. Credentials. Oh, you can use the password 1234 and any login to enter. Any login works, so any username. All right. So 10.60.100.3 port 5000. For yeah, I'll just use admin. And as long as the password is 1234 and you're in. All right. So you get this nice, interface, and nothing's really happening here. Okay, nothing really happened. There's nothing happening here. This is just where you would see where your flags are being submitted. All right. We have to add exploits. How do we add exploits to our amazing, nice, and interesting exploit farm? Well, we are going to talk about that. So you guys are going to have to set up the destructive farm client on your own machines. Of course, you can run the destructive farm client on the server as well. But for now, we're going to run it on our own machines. So destructive farm client, this is where you will run your exploits. So you run your exploits on your own machines. And this is better just so that, you don't have to worry about uploading your exploits to the server and all that stuff. Although obviously, if you want your exploits to be running overnight, you would upload it to the server. Okay, but in a real competition, usually they don't leave the game network open 24/7. Usually there's like, oh, you're gonna play from 8 a.m. to 9 p.m. and then we're gonna close the network. So you don't have to worry about that. But anyway, for those of you using Windows, I'm sorry, you really shouldn't be using Windows for these kind of competitions anyway. I hope you have a Linux terminal somewhere, WSL or a VM or absolutely anything at all. But if not, I'll try my best to try and accommodate you and teach you how this runs. So essentially, because we're going to be downloading a Python script onto our machines and running it. So if you're on Windows, manually go to this link. So I'm going to copy this command right here. If you're on Windows, manually go to the bit.ly link and just download that Python script and save it somewhere that you can run. All right. If you're on Linux, run the command as is. So since I'm on Mac, and that's pretty much Linux in disguise, I'm going to go to our nice folder that we created, HITB training, and download the script. Right. And I downloaded the start exploit.py. I'm going to just make it chmod plus. Right, just so that it's executable. And now we have to start the exploit. Okay, we can start exploit, and we're going to take a look at the arguments. Okay, let's look at the arguments here. So what are these arguments? So you can see here that we're running start exploit.py. Okay, that's our destructive farm client. We're giving it as an argument the exploit. This is the exploit file. So this is the exploit we're going to run. In this case, I called it exploit.py, but I'm actually going to pass the full path to my Python exploit. Server URL is where the destructive farm server is. Okay, so in my case, it's .100. Okay, so you got to point this towards your destructive farm server. And in my case, an alias is what you want to call this exploit. What is this exploit I'm running right now? So let's fill this out. What do I mean by this? So where is my exploit? My exploit is in workspace, CTF training, services, nasarasa, exploit, db exploit.py. That's the full path. And the alias, what do I want to call this exploit? I want to call this NASA rasa underscore MySQL. That is the name of the exploit. And I hit enter. Oh, okay, so the dash is weird. There we go. And it's connected. And all of a sudden you get this wild output. And what it's doing is that it's looping my exploit script immediately across all the teams, immediately stealing all their flags and sending them right now to my destructive farm client. So I refresh, I see that all of a sudden I got all these flags stolen from so many different teams. Some of them are queued. So you can see that destructive farm is waiting for a couple of more seconds before it sends more flags. and we go to the scoreboard, you're going to see I should be flying high right now. Let's go. Where is org1? Orgs1. Why didn't it update yet? I'm pretty sure I stole more than one flag. Trust me. I think we just have to wait for the check system to kick in. Come on, check system. I stole more than one flag, I promise. I will wait for it to wake up. There we go. Where did I go? Holy crap, I jumped 4 positions. I immediately gained 7,000 points from stealing 168 flags. Hey, AI, that's all right. I shared the slides earlier. I think I can copy the slides again for you. Yes, I can do that for you. No worries, my friend. Here you go. I hope that works. Yeah, so I'm uploading the slides again. There you go. You can follow along, catch up to us. No worries. So as you can see right now, I am jumping on the scoreboard immediately. Destructive Farm is receiving all these flags, and I can go back to my terminal, and my exploits are just gonna keep running. Every 50 seconds, my exploits are gonna run just before the new round or just near the end of the round. And see, now it's launching attack number 2, and I'm gonna steal a bunch of, I'm gonna get a bunch of flags all over again as it runs my exploits all over again. Okay, and that's the whole point. That's the beauty behind an exploit farm. All I got to do is just keep this running. I can forget about it. I don't have to worry about anything. I don't have to worry about no duplicate flags. I don't have to worry about expired flags. You know why? Because the exploit farm is actually the one that submits the flags to the check system. So what's going on here? My client is running the exploit, gathering all the flags and sending them to the exploit farm, the server right here. The server receives the flag, checks if it's already submitted this flag before, checks if this flag is valid, and then submits the flag. You see, so you don't have to worry about duplicate flags. You don't have to worry about anything. The exploit farm takes care of all of that for you. It does all that for you. All you got to do is just feed it flags, and it'll just keep throwing. And I can even see, I can take a look at the rejected flags right now. Like I can filter, show me all rejected flags, and I can see, you know, there are some flags that are already submitted, some flags that are too old. And so it will remember that, oh, these flags are too old. If I get them again, I should never submit them again. And that's that. Again, I cannot emphasize how important it is to have these exploit farms running. If you try to play an attack defense CTF and you don't have an exploit farm running, you might as well just manually keep running your exploits every 60 seconds, and may God have mercy on your soul, you know, because it's going to take you forever to try and catch up with these teams who are also using exploit farms. All right. So I'm giving you guys all a second. So now let's talk about patching. So quickly, people are stealing flags from each other. What can we do? Well, you can patch. How do we patch? Well, that's very simple. So first, before we talk about patching, let's talk about effective exploits. So when you build an exploit, you have to keep these questions in mind. Can you ensure that your exploit bypasses some simple fixes? So this doesn't apply in this case, but what if there is some SQL injection bug and you wrote an exploit for it, and you notice that some teams are simply filtering the word select or union from the payloads? You should make sure that your exploit bypasses all these simple fixes. Encode it in hex, encode it in base 64, change spaces to comments, all that good stuff. Pretend like you're evading a web application firewall. Make your exploit as complex as possible, encode it many times if you have to, so that you can make sure that the only way a team can stop your exploit from running is that if they actually fix the core cause of the exploit. Okay. Second, very important, how can you ensure that your exploit isn't wasting time on broken services? What if a service is just dead, it's not responding? You don't want your script to stay there for 60 seconds hung up, hoping that you know, it's just wasting your time, or you could be attacking other teams. And how can you optimize your exploit to run as fast as possible? Time is important. Okay, trust me, you do not want an exploit that takes 5 minutes to run. You got to keep trying to squeeze every millisecond, right? You don't have to worry too much because the flags again expire in 15 minutes. You have 15 minutes to grab the flag, but you don't want to waste time. Okay, you don't want to waste time. All right, let's come here. So how can you guys protect yourselves? So a lot of you guys are like, oh my God, my flags are disappearing out of thin air. What can I do? All right, very simple. I'll tell you what you can do. Let's talk about patching. So we can either prevent the database from being exposed to all players, or we can change the password to the database, or both. All right. So the database doesn't need to be exposed. Everybody knows the #1 rule of databases is you never expose them to the internet. Let's change that. All right. So let's go into our NASA RASA service. Let's look at the Docker Compose file. Okay. You see this ports right here. What does this mean? This means that it's taking port 3306 inside the container, okay, and it's forwarding it to port 3306 on the host. But if you don't explicitly specify what IP address to listen on, it will listen on 0000, which is exposed. So we can simply tell our database, hey, why don't you listen on localhost instead, okay? Still, keep the same username and password if you want to. Nobody will ever be able to touch it anyway. So why bother? Just make it listen locally, all right? And I got to check if this actually works. So let me make sure. So I'm going to say, again, build, force, recreate, and -d, MySQL. Okay, it's not called MySQL. It's called something else. But here we go. And I do Docker PS. And you see MySQL. MySQL, it says here that port 3306 is forwarded, but locally. If you guys try to log in, I want you guys to try and log in now. You guys know the MySQL command. I'll send it over. See if you can log into my database. Okay, so I'll give you team 3 like this. Here you go, and run this. This is you attempting to connect to my database right now. You can try, but you shouldn't be able to. It'll just tell you that you can't connect. The IP address, the port is not open. Am I right? So tell me, can you guys connect or you can't connect? Tell me in the chat. You can't connect. And that's one thing. We just solved the database from being exposed. That's a simple line. All I did was change the Docker Compose file, and you can see all I did was add this extra line. I made it explicitly listen on localhost, which means my service can still access. So NASA RASA, the PHP service, can still access my database, but they can't. Other teams can't access my database. So now people are, I patched myself, and I'm going to stop losing flags. All right. So I'm expecting all of you are going to start doing that really soon, and it's going to be almost impossible to steal flags from other people regarding this specific vulnerability. And that's more than fine. That's how the game works, right? And let's say you want to change the password. Right? Just for the sake of security. If you do change the password, you're going to have to remember, you have to change the password somewhere in the code. So if you look at the code, let's go to INC. You see there's a db.php. There's a database.php right here. And so this database.php, again, the credentials are in the code. So whatever password you change outside, you have to change the database credentials right here. Okay? Just to make sure that my service is running fine, that NASA RASA is not complaining, I'm going to actually go to NASA RASA right here and check that it can actually access my MySQL database. And again, I get no errors. Everything's working just fine. Right? And so that's one vulnerability we just patched right now. If you change the password or host the database locally, is that the legal way to patch? Yes. So that you are allowed to patch any way that you want. Okay, that's fine. It's fine that you joined a little bit late. You are allowed to patch it like that. Change the password and host it locally. That's more than fine. Again, why are we changing it to locally? Because the check system never, almost rarely cares about your exposed database. So you're going to notice I'm not losing SLA. Why am I not losing SLA? Because, well, because the check system doesn't care. It's not about the database, it's about the service. Okay. Now let's say that for some reason the check system is actually checking whether your database is up for some reason. Okay. In that case, don't make it listen locally. Just change the password. And that's more than fine. You're allowed to do that. It's even better to change the password and leave the service open, because that might waste time in other teams trying to connect to your server, because they actually have to connect and negotiate and be like, here's the username and password. Oh, that's incorrect, which is a few milliseconds slower than getting an error that the port is just closed. Yeah. So you got to think about it like that. Will there be multiple vulnerabilities, like more than 3 on the application? Well, that's pretty much up to the service. Sometimes there are unintended vulnerabilities. Sometimes you can patch a vulnerability and introduce another one. Sometimes you can, sometimes the database is exposed and there's just one more vulnerability apart from that. It's really up to the service. It could be anything. You just have to keep looking. Keep stealing exploits from other teams. Keep an eye on what's being exploited. Keep an eye on what's happening, and you'll be able to find out. So moving on. So we finally exploited our first service, and we finally patched our first service. But guess what? There's another vulnerability in Nasrasa. We're not done yet. We are more than done. I mean, not more than done. We're not done yet. Okay, we have a long way to go, right? There's an actual vulnerability in Nasrasa. And let's talk about that. So look again at the docker compose.yml and db.php. Is there anything that catches your attention? Well, let's go. Let's take a look. Now, I want you guys to take a look and tell me, does anything catch your eye? Is there any specific settings that are being enforced that you usually don't see when you're just trying to set up a database? There's no wrong answers. You guys can keep asking. That's fine. Keep guessing. Just tell me in the chat. Do you see anything catches your eye? Something that okay, root password. So what are they doing with the root password? So the root password, they're just setting an environment variable here, random root password. They're setting it to yes. And if you go look at the documentation for Docker MySQL, you'll see that this just randomizes the root password every boot. So that's fine. That's okay, but good job. You paid attention to something. All right, what else? Are there any specific options that they're setting? Any specific options that they're overriding? I'll give you a hint. It's not in the Nasrasa www at all. It's here. It's right here. More importantly, it's right here. Yes. So something in the command, they're enforcing a specific character set. Okay. I know you can't see the full command, but that last part doesn't really matter. The skip character client handshake, that doesn't really matter. It's this part right here. So they are setting a specific character set. And you might not be familiar with this. That's fine. You're like, okay, maybe this is hard to catch. How am I supposed to understand that? How am I supposed to catch that? But you should always Google everything. And you're about to learn about a very interesting vulnerability that you can have in MySQL if you pick the wrong character set. Okay, so there is a vulnerability that exists in MySQL. Well, it's not exactly a vulnerability. It's kind of a logic bug, and it's not available by default. It's only when you pick a specific character set. So you can change the character set, okay, that the database is using. All right, you want the database to use a different character set. And we are enforcing a character set right now called UTF-8 MB4 Unicode CI. All right, and if we Google this, so let's learn, like, is there anything happening here? And you can read and you can try to understand what's happening. Okay, but for now, let's look for the actual MySQL reference. Okay, and let's try to Control F and look for our. So we see right here that there is an attribute called pad space, and other versions, other character sets don't have this pad space attribute. You can even try to set up your own MySQL database through Docker. You'll realize that they don't set pad space by default. Now, what does pad space mean? Well, its results can be very catastrophic, especially when trying to do authentication. Let me log into my own database. All right. So I can log in with my own database with the same credentials. Okay, because again, I didn't change the credentials. I only made it listen locally. Here I am. So in SQL, if you do select hello, okay, equals hello, what do you think the output of this is? Is this true or false in SQL? It's true. Yeah, hello is equal to hello. 1. You get a 1. Hello is hello. That's correct. Now, what about this? Hello equal to hello space. In any other programming language, hello equals hello space would give you false, right? Because it's not the same. However, because of the specific character set that we're using, and it has an attribute called pad space, when you run this, you get true. Can you imagine what that leads to? Imagine the following statement. Select star from users where, and then username equals admin space. You can now, using this, you can now log in as other users, because MySQL, thanks to the pad space attribute, it will ignore. You can add so many spaces here. You'll still get 1. Do these two strings look the same to you? They don't look remotely the same. Hello equals, and then hello and a million spaces. But because of pad space, it ignores white space. It ignores trailing white space when doing comparisons. And that is the main vulnerability inside of NASA Rasa. How does that vulnerability work? Why is that a vulnerability? I can show you right now. Let's go to my own service. All right. I'm going to go to my own. This is my own NASA Rasa service. And I'm going to go to the users. And I can see that the check system here has inserted. Let's go to this user, because we know this user was created by the check system. This user signed up with this username. I'm going to take their username. Okay. And I'm going to sign up. I'm going to make a new username. Same first name, same last name. And the username, I'm going to add a space at the end of the username. I'm actually going to add 2 spaces for good measure. And the password is just the same username. And I'm going to sign up. When I click on my username, the database gets confused. It thinks that I am the same username that the check system placed in. And I can see here message visible only to you. And I get the flag. Thanks to pad space, and this vulnerability is known as pad space collation, right? I'll type it in the chat, pad space collation. All right, because of the character set that I'm using in MySQL, I can now bypass authentication, because I can simply sign up with a username that has the same username as the user that I want to log in as, and add so many spaces to the end, and then just log in. And when the database comes to show me information, it will get confused. It will think that I am that original username with no spaces. And it's going to show me, it's going to give me access to the private messages right here. And so that's why if you go right now to users, this is what these people are exploiting. They are creating random usernames. All right. They are signing up with the same, they are signing up. And you'll notice, look, if I select this, oh, well, it won't show me, but there's actually a space. Okay, there's actually a space. That is what the exploit is. It's taking the latest username, okay, taking the latest username that the check system placed in, and we know it comes in the form of like two names like this, okay, and reading the username, going to the main page, creating a new user while adding spaces at the end and signing up. And then you go to your own page and you'll get the flag. That sounds a little bit complicated. And you're like, wow, I got to run this every second. And we have a couple of issues. So many people are running the exploit. Look, the number of users is just a bunch of garbage right here, right? How am I supposed to filter the garbage from the actual users? And I'll tell you something even sneakier. If we take a look at my exploit, okay, let's take a look at my exploit. This is my service exploit right here. I'm using a couple of important libraries. I'm using Beautiful Soup, which allows me to parse HTML. If you've ever done web development, Beautiful Soup is kind of like jQuery, right? Or document dot, get element by ID, get element by that stuff. Lets you move through HTML. All right. And I'm using the requests library to make HTTP requests. And this faker library, we're going to get to it. So again, the script works the same way. I got the host IP address, okay, host IP address right here. And I'm starting a request session. So the reason why I do this is any cookies that I get or anything are saved. And I'm going to the /users page. The first thing that my code is doing is it goes to the /users page and it takes the HTML and it feeds it into Beautiful Soup. And I look for a div with the class user. How does that look like? Well, let's go to the users page. Let's go to view source code. I'm looking for a div right here. I can see this div right here with class equal user. Okay, that's exactly what I'm doing. Div class user, and I find all links. I'm trying to find all the different links right here. So these guys, /users 1790, /users 1789, /users, all that stuff. I'm trying to get all that, right? Now, the next step is that I go to that user's page. So my script starts going to these links right here. It starts going to them. Okay, only the first one though. It only takes the top, which is actually a bad thing in my script. I shouldn't only take the top user, because what if the top user is something like, in this case, it's not the check system. The check system didn't put this. This is by another team trying to log into my service, right? So I should actually try to loop over all of the links that I get. Okay, but in any case, let's just focus on this right now. So I try to I look for a span with the class label success. Let's see how that looks like. So let's click on any of these guys. Let's click on this guy and let's view source code. Let's look for a span right here. I see here span label with the class label success. Okay, why do I look for this HTML element? Because it contains the username. Look, they registered at time blah 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 as, and then their username, and that's what I'm looking for. So I'm extracting their username. You can see here that I split by the space. Okay, I split by space, and I get the last element in the array. So if you split this string right here by space and you do of element -1, you'll get this one. So I always get the username. Then I initialize faker. Why do I do this? Because look how I'm signing up. I'm signing up. So I go to the sign up and I send a post request. I send first name equal fake first name and fake last name. I am making my signups look like as if they came from the check system. Okay, what does that mean? Let me show you. So I'm going to do Python. Okay, from faker import faker. I'm going to do fake equal faker like this. And then look at this, fake.unique.first name. It's giving me random fake first names. And I can combine this plus space plus fake.unique.last name. And look, it's fake full names, just like the check system. My exploit signs up rather than this obvious chaos that's happening right here. If I go to my users list, okay, rather than this very obvious chaos that's happening right here, I can clearly tell something is happening. I'm being sneaky. I'm trying to stay under the radar. I'm signing up with very normal names. Okay, why would I try to scare the people who are running the service by signing up with a name that very obviously looks like someone is logging into my service? Get me? So that's the idea. So I'm using this faker library to sign up with fake first names and last names so that I'm stay under the radar. And you can see right here that I log in with latest username plus space. I add a space, and you can actually, I can multiply this space, for example, with a random, like a random number each time, just in case I want to evade any detection. In this case, I'm just going to multiply by 4. I'm just going to post 4 spaces. All right. And I generate a random password, again, using faker right here. So fake.unique password, length equal 30, special characters equal false. Okay. And that's pretty much it. I sign up and I log in with the new user. Okay, I log in and I immediately grab the flag from a div. I find a div called with a class planet message, and I just grab the text, and that's pretty much it. Now let's loop this. Let's loop this because this might be wrong so far. So what I'm going to do is time to do some development live on stream. Okay, so find all, and I want to print latest users href. Comment out the rest. So I want to loop over all the users that have signed up. Okay, terminal services, Nasarasa, nope, Nasarasa, exploit, service. I call this exploit service exploit, and I want to point it at myself. Okay, none type object is not callable. What is happening? Why is this not working? Okay, it found one. What if I want to find all? Hello? Oh, it's find underscore all. Okay. Yeah, you got to be careful. And I get an array. What? That doesn't make sense. Yes, development. I love development, guys. Don't you love development? Why is it not giving me an array of all the links? Ah, here we go. Beautiful soup. Get all links. Oh, it's find all. I tried find all. I swear if it gives me an error, but I still got that makes no sense. Why? I'm pretty sure I have more than one user. Look at this. I have like 1 billion users. Why are you doing this to me? Find all on the first find. But I don't want to find all divs. You get me? I don't want to find all divs. I want to find, there's just one div anyway. You get me? If I come here and I open the source code, there's only one div on top here, div user. Oh, there are many users. Oh, I'm so sorry. You are right. You are right. You are right. Oh, I am very stupid. Thank you. Bless you. All right. So now we're gonna have to loop over all these guys. I see. Thank you so much for making me pay attention to that. So for user in latest user href, I have to take user link, for example, equal user dot find a dot, and then how did they do it here? Dot get href, and let's just try that user link. There's a way of automating this, right? Because if you notice something, there's kind of an IDOR vulnerability here, right? You know how to go to every user and there's just a number right here? I can literally just take this number and loop like 20 numbers back. So there are so many different ways of writing this exploit. I don't need to worry about, I don't even have to do the whole parsing this HTML. I can just literally just come here and just, start messing with this number. But yeah, let's just continue what we're doing though. So let's run the script one more time. Wow, and I get a link of all the users on the board. That's nice. So I'm just going to come here and I'm going to uncomment these guys and I am going to grab the code, this code, and I'm going to paste it right here. Got to be careful with Python because it loves its indentation. So we are going to user link and it grabs the username, latest username, and we're going to print latest username. So this should get us a list of all usernames. All right, it didn't work all the time, and that's weird. Why did it not work all the time? Let's just print this. That's odd. It should have worked. Why is it working sometimes and sometimes not? I mean, maybe it's filtering duplicates. I can't. Oh, some names have extra spaces in the back. You're right. Wait, that's actually good. That is actually good. That's actually good. That means we're ignoring the usernames with extra spaces in the back. Isn't that good? So I can come here, for example, and say, I'm going to make an empty array here called users, let's say check system users, and it's an empty array. And if latest username, all right, does not equal just a space, right? If it's not just a space, then we can add it to our array of usernames to exploit. So now you can print check system users and you'll have a list of users that you know for sure what happened here. If latest username is not, you know what? Okay, let's just say I think there's dot empty. How can you check if we can just do dot strip, to be honest. We can just, you're actually right. You can actually write if, yeah, that's actually good. That's good. Wow, you guys are Python experts right here. Everybody is. I thought I was good at Python. There's a billion ways to write it, thankfully. Yeah, I'm going to go with that one. So if length and while it's stripped is still greater than 0, then we append. Yeah, that's right. Let's do that. Nice. There we go. We got 2 usernames directly from the check system. We know that these usernames were generated by the check system. And just for debugging, I'm going to print just for debugging, I'm going to print this. Okay. And there we go. So these guys probably have a bunch of spaces at the end. Yeah, well, I don't think my terminal is accurate, but yeah, there you go. You grabbed users that were only placed by the check system. Again, if you guys are like panicked and you're like, oh, what if these were not placed by the check system? What if, what if what if we actually wanted to try and exploit them? That's very simple. All you got to do is just come here and strip the text itself. Okay. And I think, so this will give us a complete list of usernames, even the ones that might be fake and put by other people. Okay. That's fine. See, but what we want to do is we want to make sure they're unique. So I'm going to create a set over here, a Python set, and I'm going to say check system users dot, how do you push? Is it append? Append into a set. Yeah. I mean, it's not, it's complaining, but you should be able to append into a set. Oh, that's a dig. Oh my God. Sorry. I'm just going to do set like this. Yes. Yes. There we go. Why are you complaining? Set. See, it's not called that. I think it's add in a set. A set, it's add. Yes. There you go. Thank you. There we go. We have a unique set of usernames. All right. So now we increased maybe the potential of our script finding even more vulnerabilities, even more usernames to hijack. Okay. So what are you going to do? Very simply, we are still going to do this. So we're going to loop over. I'm going to uncomment all this. All right. And I'm going to loop for user again in check system users. All right. So these are the users we want to exploit. We are going to sign up with that user. So I'm going to do user right here and 4 spaces. We are signing up with 4 spaces for every single username. Okay. And with a random password every time. And we're signing up with that user. Okay. If the sign up doesn't work, we leave immediately. Okay. Then what happens next is we log in with that user. Let's come in here. Let's tabulate that. We log in with that user. If the login doesn't work, we exit the script immediately. Oh, what happened? All right. There we go. No, please. Okay. And last but not least, we are going to uncomment this part and we're going to get the planet posted by the user. We're going to try to find the, so we're going to take this. I'm going to separate this on a different line. I'm going to put a try catch, okay? Because what if we're accidentally logging in, I'm so confused. I'm trying to write like 3 different languages at the same time. Okay, so if for any reason there's an exception that happens, for example, this user doesn't actually have a flag, okay, then we will just continue. Otherwise, we can print it. Okay, so sometimes some users will be fake users put in by other people, and we don't want to worry about that, right? So there we go. Now we can try running our script. Everything looks good. Everything feels good. Oh God, failed to parse. Whoa, what is happening here? I think we need to call it something else other than user, maybe. Let's just call it exp user, just for the sake of, And we had to change it right here as well, I think. Ooh, get the planet posted by the user. And we have to go to their, oh, that's going to be interesting. How can we do that? I need to somehow get their profile number. How can we do that? How can we get their profile number? There are so many ways to do it, but I mean, you could do it could be a set, you could do a dictionary. So you could be pushing dictionaries, but I don't think that will work though. So let's say, for example, user is this, and then we're pushing an ID, and let's say user link. Okay. So for AXP user, don't worry about what I'm doing. I'm just mumbling to myself, but I know what I'm doing. For those of you who are fast enough to understand what I'm doing, that's amazing news. ID. I think that might work. Unhashable type dict, of course. Of course, I was doing this to myself. Use a tuple. Yeah. So we'll use another tuple like this. It will be user link and latest username. So essentially what I'm trying to do is I'm trying to save the usernames and their link to their profile page at the same time. Okay, that's what I'm trying to do. So that when I do the second loop of only unique users, I have access to both the link and the username. Thanks for that. So let's see what happens now. There we go. And we're grabbing flags. That's great. So we now have a working exploit, and that's amazing. And you know what? I can immediately copy that same start exploit command. Remember for the check system, sorry, for the exploit farm, I can just copy that same command again. Let me copy it. Where was it? Somewhere here. Come on, where are you? Start exploit.py. There we go. Okay. And I can actually just come straight up here, and I'm going to change these dashes. And so what is this exploit? This exploit is NASA Rasa web. Okay. And my server is at that IP address, and it's called -- server URL. And the exploit is located in workspace, CTF training, services, NASA Rasa exploit, NASA Rasa, what was it called? Service exploit. And there you go. Oh, sorry, I wasn't in my HITB training. And there we go. A brand new exploit, just like that. And that's fine. Some people have their services down, so you're getting this connection refused bug. And that's okay. There we go. I'm stealing flags from other people. Some teams have their services down, so I'm getting these exceptions. But that's fine. Yes, thank you, Andre. So your exploits can output. So Andre is making a very good point that your exploits can contain output other than flag. You can print other stuff. That's fine, because the farm will actually use the regex to only pull out the flags from your output. Okay, and so there you go. Now, if I go to my exploit farm, let's reset the zoom on this. You see that I now have two exploits. I have NASA Rasa web running and stealing flags, and I have NASA Rasa MySQL running and stealing flags. And like I said again, the beauty of the check system is that I don't have to worry about any of that. I wrote the exploit and I launched it, and I can leave it going on exploiting the other teams. Okay. Go back and look at the scoreboard. I've stolen 562 flags, and I think nobody stole any more flags. No, I think I'm still losing flags thanks to the pad space collation. So let's talk about the pad space collation. What is the easiest way to fix this bug? We need to fix this pad space bug, right? How do you fix it? Well, the best way to fix it is just to come down to this command part and just stop setting a specific character set. Why are you trying to set a specific character set? Just use the default. And the default one in MySQL doesn't have pad space collation, by the way. So just turn it off. And there you go. I'm going to rebuild my database. So Docker compose up -- build -- force recreate -d. It's rebuilding and it's up. And I can even go like this. Let me again connect to my database locally, and let's check. Can I do that trick? So can I select hello equals hello space? I get 0. You get false. Okay. You've successfully patched the patch space correlation. Although, by the way, you might think that's it, but there's another secret somewhere in here. All right. If you look at the db.php, you can see that when it creates tables, when it's creating tables, look, it's forcing a specific collation. Look here. It's forcing that collate. It's forcing that character set on the table. So you're not done yet. You should investigate the code. So the final piece of the puzzle is to remove this and keep it like this. Now I have to rebuild my service as well. So don't just remove from the Docker Compose and think that your life is okay. You should investigate all the code. See if that word, that phrase, you know, this UTF-8 MB4 Unicode CI, see if it exists anywhere in the code. Try to look around. So now I can fully 100% patch my service. So I bring it up. It's rebuilding. It's going to take longer now because I actually changed the code for Nasarasa. And I'll show you that my service runs perfectly fine. Yes, AI, you will have access to these once the training is done. Yeah, you guys will be able to see all these. And there you go. My service is running. Let me just make sure that my services actually haven't destroyed my service. So let's go to Nasarasa, and there you go. It's running perfectly fine. Service is up and running, and I'm patched. And I'm gonna stop losing flags while still grabbing flags thanks to the exploits that are continuously running from other teams. And that's pretty much the beauty of attack and defense. You can even see, by the way, see right here how often attacks happen. So you can see that coffee pot, there are 14 attacks per round happening, or 14 flags being stolen per round. 72 flags per round, 52, 66. This gives you an idea about what services are most commonly being exploited. All right. We can move on with the material now. We still got services to look at. So I'm going to give you guys another. Can you try running my exploit again against my own service? Yes, that is actually a great idea, since you want to make sure that it's fixed now. Please move away Zoom thing. All right. Here it is, right? Run it against my own service. Nothing. This is the database exploit, right? Let's use the service exploit right here. It's just probably waiting. It's going user by user, trying to sign up, and nothing happened. There you go. I get no flags anymore for my own service. That's proof that we patched it. When other teams try to, mess around, and you have to keep exploring. Maybe there's an extra bug. I mean, right now we know that there is no, I'm telling you that there is no extra bug, but you never know, right? So there we go. You're patched, and you've saved yourself from your flags being stolen. So now we're going to go on quite a bit of a long break here. We're going to go on a 30-minute break, okay? Just because I've been talking for a while. And I want you guys to go ahead, go look at Coffee Pot, all right? And try to figure out what the vulnerability is. So we're basically done with material, okay? But I am going to walk you through the vulnerability in Coffee Pot as well, okay? So I'm going to put us again on a 30-minute break. You guys can go ahead and take a look at Coffee Pot, or if you feel like you don't want to take a look, just at least go drink water, freshen up, and be back here in 30 minutes. All right, we'll see you guys in 30. All right, welcome back everybody from our 30-minute break. So, tell me guys, what have you found so far? What vulnerability have you found in the coffee pot service? Nobody? Anybody at all? Command injection. Yes, there is a command injection, and that's fine. And that's fine, Antoine. We'll get to it right now. I'll explain it to you. So there is actually command injection in coffee pot. All right. So let's take a look at the code together and I'll point it out for you. All right. So let's go to my machine. Let's go to CTF training. And let's look at the service. All right. So coffee pot service. And let's look at coffeepot.cgi. Okay. So let's see here. So it says here that the coffee pot is implementing RFC 2324. Okay, what is RFC 2324? If we go on Google and you find out, this is the hypertext coffee pot control protocol. All right, it was an April Fool's prank, but it's an actual RFC, how to control coffee pots using HTTP. It's a protocol used similar to HTTP to talk to coffee pots. All right. And we can see here, and let's try to find out where the bug is, right? Do you guys have an idea where directly in the code the bug is? Do you guys have a line, for example? If anybody found it. Line 81, where it is taking your input and running echo next to it. That may be correct. So we can verify because I have the write-up right here. So we can actually walk through the write-up. Let's see here. Can I get my hands on the write-up? So it turns out that the only bug, or the only known bug, is this line, actually. Echo addition count +1. Okay. 85. Well, it's 87 on my, which is this double brackets. You see how all of them are curly brace, except this one is double bracket, double curved bracket. So that indicates that this is not being filtered properly. Okay. And so to exploit the bugs, the attacker could send this value as an initial ingredient count. Okay. It clears out the file due to error when +1. Well, what happens is that you could pass this as an ingredient count. You can cat all the pots, grep the flag, and store them in a pot that you control, pot 1, 2, 3, 4. Okay, and then you have to ask the service to add one more ingredient, and then that command gets executed. Okay, this is a very simple example of the exploit. All right, is that you're trying to create you're trying to add an ingredient, rum. How much of that ingredient are you adding? Well, you're adding this, and you're injecting the command cat pot / grep flag and put it in a pot that you control, pot 1, 2, 3, 4. Okay. Then you're creating some random pot and you're telling it to create that coffee pot with that ingredient, and you can now go and grab pot 1, 2, 3, 4. Okay, you can now grab the pot 1, 2, 3, 4 and take the grab the flags from it. Okay. guys, sometimes you're just like, what is happening? So let's just go to coffee pot. Okay, it's on port 3255, right? So 10.60.100.3 port 3255. Okay, you can see that you can add. All right, so let's choose a pot. Let's choose pot 100. Okay, we're gonna set, right? And we should actually open the network here so we can see requests that are being made. So you did set, okay, and you can just look at the headers. So you use the prop find method, okay, and you just initiated pot 100. You're like, I'm going to create a pot called pot 100. And you're like, okay. And now we're going to add. So 1, 2, 3, 4 of ROM, and it's trying to give us a sample flag. Okay, and we're just going to keep this as is, and then we're going to start. You can see that we see brew, and then it does prop find one more time, and there you go. Okay, so it's brewing right now. So pot 100 information, brewing. Okay. Any other questions? And we can stop it. And it just says nope. Okay, looks like we can't. Looks like we can't stop, and we can keep adding ingredients right here. Okay, put, using the put, we're adding rum. And that's pretty much it. You guys are probably like, what what is happening right now? Well, let's see what is inside. So let's try to do this. So curl, okay, we're going to do -x prop find. Okay. 10.60.100.33255 pot 100. This tells us, it gives us the information about this pot. That's what it does. So we have 1 almond milk, 1 whole milk, 3 almonds, 4 whiskey, 6 rum, the flag, temperature, and the state. So you can, if you can do command injection and you can create your own pot, you can change one of these to contain just a list of flags. And that's exactly what we're trying to do. The amount that we're adding, we're injecting into the amount that we're adding. Okay, that's where the command injection happens here. It would be better if I had burp or something. Let's try to find the put request. Okay, you see this? Accept additions. So we're trying to tell it to brew. And what are we brewing? We're brewing, and then there's a header called accept additions. Okay. And it's putting whole milk, 1 of whole milk, almond 2, whiskey 3, rum 4. All right. And so the vulnerability is this count, this number right here, as it tries to process it. Okay. It comes here, and when it comes to run it, that actually creates a command injection. That count that you send. I might not be making sense. Am I making sense? I don't know if I am making sense. Do you guys get me? Do you not get me? Are you kind of confused? Are you like, show us the exploit and we'll understand? Confused. Okay. All right. Okay, I saw that coming. Okay. So let's map it out in text. Okay. What can we do? So we can prop find, okay, and a URL pot and some number here. This gives information about pot. Okay. What else can we do? We can, looking at these requests right here, we can use the request brew, okay, / pot xxx starts brewing the pot. Okay. However, when we brew, pay attention to brew. When we brew, there is a heading called accept additions, which lets us specify the initial number of ingredients. So this, I'm going to tab here and make accept addition. Lets us specify the number of each ingredient. Then finally, we have the put method. Put right here, somewhere right here. Come on. Put. We have put / pot xxx allows us to add ingredients into already existing pots. What header does it take? It takes an addition header, which the type of the type of ingredient to increment. It just increments it. Okay, so maybe let's just put some separation here between these lines. There we go. Okay, these are the 3 things that you can do. Okay, you do HTTP request prop find, you get information, you can brew a pot, and it takes a header called accept additions, and you specify the number of each ingredient, or you can, and then you can, while something is already brewing or before it even brews, you can put and add ingredients into that existing pot. Okay, and the addition header lets us specify the type of ingredient. So for example, let's come here. I'm going to set my pot to 500. All right, I'm going to have 0 of everything, and I'm going to start brewing. Okay. Then I want to add, let's say, 1 milk. Okay, so let's look at the latest request that's going to happen. Click, and I can come here to try to find the put. See, what do I want to put? I want to put whole milk. So that's the type of ingredient, and it will increment it in the code. Looking back at the code. Okay. If you are trying to put something, okay, and it's a pot that exists, okay, then we read the pot for every single line. Okay, we split. This is splitting by the column. Okay, because look, when you looked at the output at prop find, let's open another formula. Let's open another terminal, and let's make this big. Curl prop find 10.60.100.33255 / pot 500. Right, it's splitting every line by that column right there. Okay, so the addition is what we're trying to add. Okay, if addition is not equal to what we're trying to add, so remember how we send the HTTP addition in the header, this one, the addition header. So it's checking. We sent, for example, in this case, we sent whole milk. Okay, whole milk is a bad example. Let's talk about rum. We sent rum. Is this rum? No. Is this rum? No. Is this rum? No. Is this rum? Yes. And then it executes. So this is what it's checking. Finally, when we get to the thing we do want to increment, it doesn't escape it properly, as you can see. This is bad escaping. Okay, this allows us to run this actual command in bash. Count, the variable count. Remember how, look, count is user input. It's reading our count command. Count. So when it comes to pass it to this expression right here, this actually executes it as a bash command. So that's why the first thing we have to do is specify the vulnerable count. That's why the vulnerability is in the count. And then when we try to add that ingredient one more time, our command is executed. Now, are you getting closer to understanding what's happening? Yes? Yes, okay. That's great. So let me show you this in practice. Let's do it from the command line step by step. Okay, I want to brew. I'm going to create a new pot. Okay, and I'm going to call this pot 1337, for example. Okay, I want to brew a brand new pot, and my headers are going to be the ingredients. So I'm going to make I just want to take a look at how the ingredients look like. There's a brew. Okay, accept additions. Okay, so I'm going to come here, accept additions, and I want to add I'm going to use the rum, for example, okay, to exploit. All right, so I'm going to say rum, and then we're going to copy the exploit. No, don't launch Discord. That's not what I wanted to do. I wanted to go grab the exploit. This right here. You see this? Instead, so usually what we put here is a number. You put a number here. But this time we're not putting a number. We're putting some sort of command bash injection. Okay? And what does this do? This will cat pots and grep the pots that contain a flag, and it's going to put them in pot 1, 2, 3, 4. Okay, let's actually change this and make this 1, 3, 3, 7, 0. Okay, so a pot with just 1, 3, 3, 7 and 0 at the end. Okay. No, please just let me run this in peace. Okay. That's what this is going to let us do. All right, and I actually almost injected myself because I was doing it in double quotations and my shell was trying to classify that. Okay, here we go. So now we created a pot 1337. Oh my God, it exists. Okay. I'm going to create pot 13371. Okay. Now, usually you would put a number here. Okay, but now we put this weird injection thing. All right. This bash injection. Now, when we tell coffee pot, we want to increment that ingredient. Okay. In this case, we're incrementing the pot. What are we incrementing? We are incrementing, and then we have to come here and see what header does it take. Where is put? Come on, show me a put. Oh, there we go. There's a put here. No. Put. It's called addition, the addition header. Okay. What ingredient are you trying to increment? We want to increment rum. And so it's going to go to rum. It's going to read this as a number, and it's going to attempt to increment it, which is actually going to end up executing our command. So let's run. It's kind of frozen for a second there. That's not good. I think I might have messed up something, but here we go. We'll wait for it to come back. You think so? You think data, it's waiting for data? You can make it verbose. So let's make it verbose. Added. Thank you. Thank you so much. And there you go. Now, if we go prop find that new pot we created, okay, 13370, we get a list of flags. It read all the pots and it dumped all their flags. We did it. Command injection. There you go. And so you can very easily write this into a Python script, and you're gonna do the same exact thing again. We can even run. There's already a Python script for this, so I'm gonna run. I'm gonna run it. I'm gonna show you workspace, CTF training services, coffee pot exploit. Okay, and I'm gonna exploit myself, and there you go. And I can immediately take this exploit right here and do the same thing I did with everything else. So I'm going to cd into my hack in the box directory, and I'm going to do start exploit, and I'm going to take this, okay, and server. What was it? Was it actually server address? Let me just pause this. What was it? server URL and alias. Okay, so I'm going to go server URL, HTTP 10.60.100.3 on port 5000. That's where destructive farm is running. And alias, this is coffee pot. And so it's already complaining because it's like, please use a shebang at the top of your script. So let's take that. And please print the new line and call flush. Okay. So let's edit our exploit very quickly to do that. So at the top here, you're going to put the shebang. And at the bottom, you're going to print, you're going to flush equal true. There you go. Okay. Let's just make sure that got put. Yep. All right. There you go. Now we can try. And there you go. That is a lot of flags. Oh, dear God. And there you go. Again, go to your destructive farm, refresh. Now I'm stealing flags from coffee pot. I'm stealing a hell lot of flags from coffee pot. That is, oh my God, that's like 10 pages of coffee pot flags. What happened? Oh, wow. Okay. That is, that is impressive. Of course, most of them are old flags, as you can see, but that's fine. All right. So we'll come here and you'll see that I am now capturing coffee pot flags. So I'm still constantly exploiting, again, NASA RASA flags, both from the database and from the service. And I'm now exploiting coffee pot flags. Now you might be wondering, how can I fix this? Well, no, they did fix it. Look, Red Rocket, they only lost 35 flags. This team only lost no flags. They patched it immediately. And the other teams are losing much less flags. Okay, so very quickly, I can just come here. And I think the way to fix this is just to make this double brace like this, if I remember bash correctly. Is my bash knowledge correct? I think that's the way to fix it. Just make it the same as everything. Well, I'll leave that up to you guys to double check. You guys can see why this is a bug in Google, how to make it bash. But I'm assuming it's the curly brace. Again, my bash experience is not amazing, but yeah. And that's coffee pot for you. So again, I know this might be a little bit scary. You're like, okay, 1 second we were dealing with open MySQL databases, and we were dealing with MySQL databases and just very simple, obvious things. Now all of a sudden, this is very scary. I don't know what's happening. How was I supposed to find that? How was I supposed to understand that? But most of you had a correct idea. Most of you knew it was RCE. You just had to find the proper place where it is. And remember, this is a very obvious exploit. If in your PCAP logs, you will see this exploit. And you can very easily see like, okay, I might not understand what's happening, but I know they're sending requests that look like this. Okay, and they're sending a request right after it to add that ingredient that they just poisoned. So I'm going to just copy the same thing. All right. So you don't need to always constantly understand what the bug is. There's always the defensive side. You can run. So most of you right now, I'm running these exploit scripts right now. Most of you right now can just go and have you can't current running. Okay. And you're gonna catch these exploits from me, from the other teams. You can even take a look about how the other teams are exploiting it. All right. Try to do simple fixes. Try to do some regex like TWY said. He fixed it with a regex filter. Maybe there's a way to bypass that regex filter. Maybe regex is not the way to go. So there's always a way, there's always things to do. Okay. Okay, let's come to the slides. I think that's pretty much it. So we're going to email you or drop in the Discord. Please join the Discord. Again, we're gonna email you or drop in the Discord a link to all the services and the write-ups soon, right after this training. Okay, please do join the Discord, because the Discord is where you will be able to ask questions when this training is over, like how much longer the network will be up, how much time you guys have before we take down the network, and all that stuff. Feel free to use that link to all the write-ups as a guide to help you find exploits in other services that you might get stuck in. However, I would tell you there are two services that we still didn't touch right now: Health Monitor and Free Life. Go take a look at them. Try to find the exploits in them. Steal the exploits from the other teams. All the exploits are running right now, so you should very easily be able to steal exploits from other teams. And you are encouraged to do it yourself. Write the exploits yourself. Launch them on destructive farm and just see the flags pour in. All right, the network, as far as I remember, will be up maybe for one more day, maybe 2 more days again. So get to work on this as fast as you can. You know that this stream and the previous stream will be up on YouTube. You guys can rewatch this as many times as you want. I'm going to upload the PowerPoint onto Discord so everybody can download it off Discord in case you missed it. And feel free to ask questions on the Discord if you guys run into any tools you want to use, if you guys run into any other questions you have about ways that you can block services or defend or stuff like that. Go ahead. And remember, there are so many services out there that you can practice on. You don't need to stick to these 5. You guys can go to the RUCTFE on GitHub. So let's just go. And you can go to the HackerDom profile, and you can see that they have a lot of CTFs that you can just go and see. Every CTF has, so let's go, for example, CTF Cup. They have services. They have 3 services, and you guys can deploy them. Again, it's just Docker. They're all Docker containers in the end. So go ahead, run the Docker containers and look at the write-ups, look at the exploits and everything, and try to solve them yourself. Look at the code. You have an endless repository, endless account of endless repositories filled with different CTFs, filled with different services that you can keep endlessly practicing on. Okay, you don't have to be stuck to these four. Of course, you won't have the entire system. That's true. So you won't have a vuln image and you won't have all that, but still, you can practice on what's important, which is finding vulnerabilities. All right. Any other questions, guys? I'm going to move my exploits very soon to my server, so they're running all the time. Okay, so even if these other teams stop exploiting, you guys don't worry. I'm going to keep running my exploits for CoffeePot and Nasarasa. All right, but if you guys have any other questions, I'm right here. You can ask them before we call it a day. Any questions right now? Hey, no worries. I'm glad. Okay, I'm gonna assume that I'm either very good at explaining or you guys just don't have questions right now. Thank you guys so much for the kind. I enjoyed getting this session with you, me and Ahmed. So thank you so much for being here. We can't wait to see you guys at the pre-qualifications and hopefully in the next final round. Hopefully, so work hard, go on the Discord, ask questions. We hope to see you there. And thank you guys so much for attending this session. See you next time.